So hello everyone. Today next REPL stream that we're doing. In the previous two sessions, we started working on a little REPL for Draco, and we got to the point where we can actually execute stuff in the console itself. I can type in simple equations to have a really over-engineered calculator. I can evaluate more complex stuff, of course, like interpolated strings. I can also add to the strings any usual operation that you can perform in the language, you can do in Draco. And the one bonus is that we wrote the lexer and parser integration in a decent way, that with minimal modification, the lexer and parser supports streaming in extra tokens from the command line if needed. So it's not constrained to just taking one line of input. We can actually define multi-line things, and the parser will actually try to read in as much as it needs to complete the parsed thing. So we could write system.console.writeLine. Hello. Let's close the function, and it noticed that we are done with this declaration, so we get a new prompt. And one thing that we are missing currently is that we won't be able to actually invoke the method directly. We also support error reporting, as you can see. What we need to do is explicitly count the context number that the function was declared in. So this is context 0, 1, 2, 3. So if we write context3.foo, that should work. The reason is it's this way is because we haven't implemented anything fancy regarding the binding logic for the REPL. Hopefully we're going to work on this as well as a bunch of miscellaneous things. It depends on how tired I get during work. So one thing that you noticed is that we have to fully qualify the name system console WriteLine. This is because we have no imports. And if I try to write an import declaration, I believe it will currently just crash as well, as it's something unhandled because of a hack we did. Yes, it's actually not a handled declaration. But what we need to do is actually carry that import declaration through all the context. So that should become like a constant import that we do from then on. So if we import system, we shouldn't have to write system anymore everywhere in any context. So imports might need a special treatment of some sorts. And let's actually do that. Let's start with something simple like that, as that's really easy to handle. We can do something like private read only. Let's do a list. And we're just going to store the import declarations. And in case, oh yeah, we need to alias it because of a stupid naming collision we have with the internal and the API syntax trees. So in case we have an import, we might not even want to do anything fancy. We might not even want to do a compilation. We just want to add it to the import declaration list, and that's it. So what we could do here is check here. And yeah, we can just return a sentinel value. And what we need to do is actually use this when we convert to the syntax tree. I purposefully factored out this function because I knew that we would want to do this. So what we can do is this dot import declarations dot append. I believe we have append, yes. Dot to immutable array. We might even have an IEnumerable overload for this. Yes, we do. That's wonderful. So that should be it for imports. So let's try it. So let's try write line. That obviously shouldn't work. But if we do import system.console, we should be able to just write write line, and now it resolves every time because we carried it on. Same should be with list. Let's try to construct a list, and that's an undefined reference. Let's try to import system.collections.generic. Okay. I see we have some things lacking in inference. That's not a problem though. So let's try import system.collections.generic, and we can do list of in 32. Okay, that seems to work. So that's already good progress. Let's commit that. And let's actually try to tackle the most annoying problem in the REPL currently, which is having to name the previous context when doing a reference. What was the code that crashed just before? I just did list. Yeah, I did list, and I believe it's because we are missing a check. Let me reproduce that. So let's try to construct a list, and we are trying to assign to an object because we implicitly wrap expressions into a function that returns an object, and we're trying to assign a list of an unknown, and we are not checking for that yet. When we're not checking for it somewhere. You're surprised we even infer an object there. Well, this is not inferred. If you look at the way the REPL session builds out your evaluation functions, if you have an expression, we explicitly build a function like this. We create a .eval function that returns an object, and here is where the assignment wants to happen in the type system. We'll deal with this later though. We'll open an issue and tackle it. It's probably not even an interesting issue. It's just an edge case we didn't handle yet. We should report that we couldn't infer it from context, and that's it. So let's try to tackle contexts and not having to type them out. And what I was thinking is that elements that you can reference usually, or rather I would say always, come from a declaration. Because the only thing you can reference in the language are things that you declare with a name. And currently in the REPL, that's variables and functions. Now, what we could do is store these things in some kind of structure, a list, or something which is really primitive, and then have a special mode in the compiler to link the top level binding scope, which is basically our symbol scopes. We call them binders, just like Roslyn, to look up from this special collected out list. Now, why would we do that? The reason we would do that is that a REPL would allow you to override a method or a variable with the same name. And the simplest way to support that is just us explicitly telling the compiler what's visible here and what's not. It will be easy to introduce this logic in the future. We might not do it now, even though I believe we have a utility function to check for function shadowing and stuff, but let's not complicate that. So let's actually look into the compilation object, because that's obviously where we'll need to stash this. Because we have, I believe we have the binder factory, or whatever we call that, it's the binder cache we handle that in the and store that in the compilation. And the binder cache is basically the thing that lazily constructs the scope tree for a given syntax, completely lazily. So you can ask any syntax node what the binder of this thing is. If it doesn't exist, it creates it, and we go through the ancestor chain and construct everything that doesn't exist yet. What exists, we do not duplicate it. So the top level is obviously a compilation unit binder. This is usually what's on the top. It doesn't have a parent binder. It actually has an intrinsics binder as a parent, which I believe just looks for the well-known types, yes. But optionally, we could, after here, wrap this binder into another binder that looks into the previously declared stuff. Now we can just do something like copy the intrinsics binder, as that's really simple. Or we might be able to just extend the intrinsics binder, but we might not want to do that because I don't think we should stop the user from shadowing things from the intrinsics scope. So I would say we can just copy paste this class. It shouldn't hurt us at all. Let's actually do that. The binding logic is in binding. Okay, that makes sense. So let's try to copy paste this. And we're going to rename this to an inject binder, maybe. If you have a better name idea for something that injects custom symbols, let me know. But inject binder sounds relatively sane to me. Actually, I saw that from the intrinsics binder we are missing the period. Here, let's add that quickly. And the inject binder basically should look like this, except we're going to take an immutable array of symbols, the injected symbols, and we're going to basically define that as our declared symbols. And constructor-wise, these are fine. Lookup local, this is also fine. This is just a linear search through the declared symbols. That's totally fine. Okay. In that case, let's do something with the compilation itself. Let's try to navigate to the type. So actually, let me try something. Can I do t:\compilation? Oh yes, okay. So I have a way to search the type directly. That's nice to know because I use this shortcut a lot. So we need a way to pass in a custom set of injected symbols, and the simplest will be to just pass that in the constructor here, but I believe we have a main constructor with all of the state injected. That's right here. And we could also we also need to store it somewhere. So where should we do that? Let's do it here. I don't know. It's... Oh, let's do internal then. Okay, that makes sense, since these are the internal symbol types. We don't want to, we don't yet want to be able to inject symbols from the API. Will allow that for the REPL, which is the REPL session itself is a type internal to the compiler. Eventually we might expose something, but not yet. Do we care about the order we add these in? We probably do. Let's do immutable array injected symbols, and then we do yes, but let's use the whoops. Let's use the fancy new syntax. I like that. And now comes the fun part, because we need to duplicate this constructor to have the option for that internal thing. As this create needs to be internal. Let's leave that here. Well, why not default it? What was the order I specified here? Yeah, let's do it like so. So the immutable arrays are in one batch. It might not be the nicest way to structure parameters, but it gives some nice symmetry to the code visually. So I believe now we can start modifying the REPL session and have something like private read-only immutable array of symbol dot builder about the referable things that we want to inject. Oh, builder doesn't have a constructor. That's actually really bad. Oh yeah, because we need a create builder. BCL, please fix this. I want to be able to just initialize it like a regular collection, please. So now, for the compilation, we can specify that the injected symbols should be just the things are in our builder. And before we forget, let's actually modify the binder cache as well to say that if the compilation has any injected symbols, then wrap this binder into an inject binder. Oh, we didn't take the injected symbols as an argument. That's actually really bad. So technically we should have wrapped the outermost scope to have these injected. Now we just need to keep track of them in the REPL session. So what we can do is that once we have a compilation, we could ask the compilation for a semantic model and ask for the declared symbol, but only if the thing was successful. So we might want to do that after we are done with the compilation. That should be fine. So how we do that is that if it's a declaration, we ask for the semantic model. And we're going to ask for the declared symbol. And if it's not null, I suppose we can add it. Oh yeah, we need to translate it from API symbol to internal. Do we have a symbol that doesn't do that wrapping thingy? We might want to modify this API. Well, the API itself can stay the same. What we're going to do is just expose the internal one as well. Get declared symbol internal maybe. And then this can be an internal. And this can return a symbol. And we basically can just ignore these two API symbol calls. I don't know why I didn't write this, write it this way in the first place, because it makes so much sense to do it like this instead. Hello, hello. Welcome new people in the chat. And the reference symbol can get the same treatment actually. So we can just call get reference symbol internal, if I can type, yeah, and then call .to API symbol. Now, in the REPL session, we should be able to ask for the internally declared symbol. I hope we didn't forget anything. Let's try to execute it and see where it goes. We have an error. Oh, because our two compilation overloads clash. Well, let's require one of these, I suppose, and injected symbols should be the prime candidate for that. And let's actually not make it nullable since we require it. Let's try to define this. Whoops, we have a regression in the binder cache. Oh, we had no scope defining ancestor. That's weird, considering we only wrapped the outermost binder, I believe. So we should not have touched anything that's interacting with syntax. as the intrinsics binder doesn't interact with syntax, the inject binder does not. So the root module is the first one that does. Oh, what's up, Draco-lang? How's my day going? Oh, thank you for asking. It's going great. A bit tired from work, but really wanted to work on the REPL, so that's what we're doing currently. Let's actually look which path fails here. Oh, the declared symbol. Oh, is it because the syntax tree is kind of stupid here? I think so. Yes, I think I know what the problem is. The problem is that, let me search for the, where's the REPL session? How long have I been a programmer for? Well, let's do the math. I'm 26 now, and the first time I started programming, I was 10. So roughly 16 years now. Professionally, I've only been working for like 4 to 5 years. So what we forgot to do here is that we do hammer the declaration a little bit here, and that might interfere with our thing. It might not be part of the tree anymore. Well, it looks like we do reference that one. As a test, let's look up the only declaration that this tree has. Just as a test, as I'm not sure yet. Let's see if this fails. Which country am I from? Are we trying to dox me? I'm from Hungary, by the way. Okay, this is half a win. We could not reference the thing, but we didn't crash. Do we not get to the inject binder part? I do wonder. Or maybe we couldn't resolve a symbol here. That's also possible. We did actually resolve the symbol. That's good. Oh, but we resolved the compilation unit. No, I don't mind these questions. I'm pretty open about who I am. You can even find my name possibly, because I did some publications as well, so it's not hard to find out who I am based on my GitHub account and stuff, so don't worry about it. So let's do index 1 to skip the compilation unit maybe. That's better, yeah. Okay. Mismatch between an object and an int32. Oh. We do not allow to a cast between an object and an int32. That's really interesting. I suppose it's because we don't do these boxing conversions yet. This might really be annoying to deal with. I wonder if we want to investigate this right now. Let's try a different one. Let's try func add. Let's try to add these. And let's see if we can actually reference the thing. No matching overload for add, so we do not do that. Can I drop you a follow, by the way? Yeah, sure. Let's see what our context is here. Did we store the function in our symbol builder? Yes, we did. What's the visibility for this thing? Let's try to ask that nicely from the immediate window. So that should be symbols1. Let's see if it is. It is. What's your visibility? It's public, so we should be able to look it up. That shouldn't be the problem. Oh, it would be really nice if we could dump out the current compilation as an assembly, and we technically can do that. It's just a little more painful. So I really wanna just eyeball it and find out what's happening, why we cannot look this up then. I wonder if we will reach the inject binder, because we do for the what is it? We do for variables. Okay. What are we looking for? Object. Okay, that's not relevant. We're looking for add, which is good because we do have that. And we even added it to the result sets. That's also wonderful. So I wonder what's happening here. We have a lookup result of that singular method. Okay, we bind this name expression. That's also really, really good. Okay, we memorize the result. That's the least important part. Then we'll go into another lookup. Let's look into the solver. We're going to the nastiest parts of the compiler, the type checker. And within that, the constraint solver that we have. Let's look for overloads and see what the hell is wrong with them. Do we ever hit that? Doesn't look like we do. That's really bad. Let's try again. Oh, we don't care about that. We have an overloads, I suppose, of addition. Yeah, that's fine. We don't mind that. That will resolve fine. And then let's try to actually invoke add. Okay, let's look at the candidates. We have candidates. And it is actually the addition, so we do find that. You're an artist. You'll make good friends with Lucille. Oh, during refinement, we discarded the candidate, which is weird. Why did we do that? Oh, I think I know. It's because the base types in 32 are referentially compared, and the different compilations currently don't share the references to metadata stuff. Oh crap. Let's look if we can hack that into the compilation actually. I think we cache the metadata assembly thingies. Build metadata assemblies. Quinox, are you mad about our hacky ways of handling type equality? It's an unfortunate mistake, but I'm not sure how we're going to solve that yet. So, because we cannot share the metadata references, we could share the metadata. The thing is that this is a bad way to cache these, because why would we want to rebuild all of them? We just need to rebuild these per metadata. So we don't really want to have an immutable dictionary here. What we want is a dictionary that optionally has an already cached metadata assembly symbol associated with it, in case that symbol is instantiated for the metadata ref. Let's try to refactor this a little. So we actually don't need the lazy initialization thing we usually do for these. Boo, mutation in the compiler. That's awful. Let's take this as an I read-only dictionary. Because we can actually transfer that now. And maybe let's not expose this. I'm not using the rename feature for a reason. I want to go through and review every usage site for this, because this is a significant change. Okay. And now we can write a function like so: private metadata assembly symbol get metadata assembly, and we need the metadata reference for it. Sure, feel free to share art. We gladly watch it, as long as it's safe for work, of course. Keep this family friendly. Okay, so we instantiate the thing here. Oh, this is a long annoying name now. Oh, I think I know what the problem will be. The assembly will point to this compilation. I wonder if that's gonna cause problems. I really hope it won't. This is a little better. And now we can do metadata assemblies. Instead, we can do metadata references. Dot select this get metadata assembly. And yeah, we can cast it and we can append the source module. That's fine by me. Is there any issue with this change? I'm not sure if we reference it anywhere. I think we do. Okay. We do seem to reference this externally from quite a few places, but it all seems to be regarding built-ins and top-level lookups. So we might need to introduce metadata assemblies as an enumerable or something. Yeah, let's do that. And I'm gonna steal the comment I had for this from the get diff, which you can't see. What was the type of this? Did we expose metadata assembly symbol directly? Yes, we did. And we're going to do something really similar to this. So we're just going to copy this. And let's actually use it here. The usage sites need the most minimal fixing, fortunately. It's like it was meant to be this all along. Okay, so with this, our compilation should be a little smarter. Now we need a way to actually carry on previous stuff, like this cache. So we carry on the metadata refs. We can expose that in the internal thing as well, I suppose. Yeah, let's do that. Now let's get back to the REPL session. And yeah, oh, one more thing is that we're going to need to keep the metadata refs around to have the same reference equality. So we're going to have to change this. That's fortunately very easy as well. We can just change this to an immutable array.builder. And we can do something like so. And when a compilation is done and we add a context, we can add the metadata refs. And this becomes really simple as well. So now I'm again starting to lose track and trying to remember what we might be missing. Oh, of course, we need to modify how we construct the compilation, because we need the previous compilations metadata assemblies in case there are any. So metadata assemblies is going to be these dot contexts dot count is greater than, let's do equals 0. If it's 0, we're going to pass in null, and if it's non-zero, then we take the last one and we reach for its compilation and reach for its metadata assemblies. Oh, of course, we changed the type of that. Can we make this internal, or should we make this internal? That's the better question. Do we have a reference to the metadata reference? No, we do not. So we cannot reconstruct the dictionary. Well, let's do something really ugly. So now in the REPL session, we can actually pass in the metadata assemblies dictionary. Thank you, Visual Studio, for blocking me from clicking with that pop-up. Let's see if we crash and burn. We do. We crash in an assembly extension when we try to look something up. Try to look up a module. The module is context 0. Okay, this sort of makes sense. I wonder why it's a problem now and it wasn't before. Oh, this is actually already code generation world, and we're in metadata code gen. So that could explain things. So we're trying to look up context 0 because this is a module reference. Oh, because it's a source. It determined that this is a source module, which should not be the case at all. It should have been a metadata reference. Why is this not a metadata ref? Well, I suppose it has to be with something I changed in compilation. Let's try something. So let's define X and then let's try to reference X. Let's see what metadata assemblies we built here as new. Of course, we do not get anything useful from this yet. From this, it should be pretty simple. What its name is? Full name is empty. Okay, that's not helpful. Oh, name is REPL assembly 0. So this is the context 0 thingy. Oh, I know what the problem is now. The problem now is that we look up the symbol in the previous compilation. So let me navigate back to REPL session. The problem is that we look up the declaration in the previous compilation, and then we inject it as a reference. And it's a source module. Of course, it will try to look for it in source. What we need to do is inject them as metadata references. So the incorrect part is somewhere here, yes. I mean, we can stash this. That's not a problem. But when we say what we want to inject, we actually want to look it up in the current compilation, which is problematic because that's going to be recursive. We have not created the compilation yet, and we still want to inject the symbols. So we cannot inject the symbols here directly, but we need to somehow be able to reference them by name, maybe. Yeah, let's try that. I know I'm iterating a lot here. This is because this is really exploratory work. I have basically no idea how a REPL works and didn't really do a lot of research on them. So we're throwing stuff at the wall and see what sticks. So internal symbols, injected symbols. Okay, we need to change this to something that represents a fully qualified name. Let's do this. Do we have aliases? I believe we do. Oh, we have type aliases. That's almost what we need. I know this is ugly. We will definitely change this before we merge, but I want to get it working so we can have something to iterate on. Actually, this can become public API now, but we won't bother with that since this can change still. So now the inject thingy will have to change a little. Hopefully not by a lot. Let's actually update the call site for that. So let's look for the REPL session. And that's not going to be that hard. We're going to .select. And then the name can be as .name. Simple. And full name is going to be as .full name. Yeah. I believe that works. And we can do to immutable array. Oh, and this was a builder previously, and we totally not use it as a builder object anymore, so let's change it to a list. I'm not sure if an immutable array builder or a list is more efficient. I suppose nothing can be too much more efficient than a list. So we'll default to that for now. And what are we missing? Oh yeah, updating the inject binder. So now inject binder won't actually take, let's see if the call site for that actually noticed the change. It should have. Where's binder cache? Yes, it should yell, that's fine. So inject binder now takes these tuple that I hate. There's gonna be frozen lists soon, which are more efficient than immutable. I thought they were already out. I'm not sure though. What I wanted to say is that I really, really do hate tuples. Especially in C#. Tuples are really easy surface. It's a really easy tool to abuse. At work we have these massive overused tuples when you have just dictionaries of tuples, of dictionaries of lists, of enumerables, of dictionaries. It's a bog to unravel all that. So tuples promote what I call primitive absorption. When you don't have proper structured things, you're scared of defining a struct or a class where you properly name things. So I'm really not a fan of tuples. I'm not sure if we want them in Draco. Maybe if we enforce naming the fields, it could be better, but then people will complain that it's annoying to use for simple things like returning a pair of numbers, but I'm not even sure that tuples are good for that. So this thing should become something lazy now. Because I don't want to re-look up everything when we request this. No unnamed tuple fields in public API is a good thing. Yeah, my fear is that to be binary compatible, sort of, if binary compatibility even makes sense, but to be compatible with C#, you technically need to use system.value tuple, and unfortunately, that has no names. Names are literally just exist in compile time, which is painful. Maybe they do exist as attributes, I'm not sure. I guess if they are in public API and you can observe the names externally, there must be some way. But to be interacting with tuples, you definitely don't need to name them, and you can even change their names, and C# won't be bothered by it as far as I know. But I generally agree that unnamed tuple fields in public API, as in no unnamed fields, is a good thing. But I wonder if the C# team have already regretted tuples, since they have record structs, which is, in my opinion, the superior thing generally. When I'm at work and I look at this tuple mess, the first thing I do is decipher it and then declare an appropriate struct, or more commonly a record struct. Yeah, it's not inherently bad. What I'm saying is it's way too easy to abuse badly. People are really afraid of GoTo nowadays, which is again a powerful tool, easy to misuse. And that went overboard to the point where people complain when you have GoTo in the language. And we do have GoTo in the language. Heck, we use GoTo in the compiler. But we went so overboard that people go way beyond to write stuff without GoTo, and a GoTo could actually have sufficed to improve the code quality for a certain case. And with tuples, I feel this is the opposite. They feel like that's a freebie to not have to declare a proper type. No, this is not the way. Do we have a way to look up a symbol? Oof. I think we should. I think we should have ways to look up the symbol. I just have no idea where that is. I thought it was on well-known types, but apparently it's not. Wait, this is binder. I wanted the type, well-known types. thought we had a lookup region here. Yeah, then we're going to do something really, really bad. No, let's actually try to tackle it in well-known types, because I believe we have lookups here somewhere. These are all looking for types. I wonder why. I wonder if we can do just to get symbol from assembly. But even that, we need the assembly here, which I'm not a fan of. I don't want to care about the assembly. We do have the fully qualified names, so technically we can look at the module. What we're going to do is roll the lookup inline here, and it's going to be ugly code. It's going to be code we need to clean up. This seems to be a theme during this session. Oh wait, we have a way to look up actually. That's awesome. Yeah, I know I'm being really wasteful here with cycles and stuff. What's wrong with this? Oh, it's an enumerable of symbols. Select many, I suppose. It really should be one, but let's observe it. Let's try to reference X, and that should build. Oh yeah, we've totally found it. Wow, it works. Can we override it? Oh, it's now an ambiguous reference. See, this is what I was talking about, that we need to maintain this context, and we need to clean out stuff that we shadow, and yeah, basically that. Let's try to assign it something more fun. Oh, we don't have random. Let's try the import feature then. Now we have an undefined reference to X. Why is that? Do we have it in the session code? Let's see. No, we didn't stash it as a symbol. Huh. Okay, that's simple, but the question is, why the hell did we not do that? Let's redo this session. So first we imported system. Yeah, we don't care. And then we defined a variable. Yeah. Oh, the symbol is null. Yeah, I'm being way too primitive with stuff like this. This is because we're writing really bad code to solve the problem, and I'm saying that we're going to rework it, but I'm starting to think that we're just causing a lot of things that are... We're making it way harder than it should be, basically. It's fine though. Oh, we can't even... we cannot even get its name for declaration syntax because it's not something factored out. Well, I guess we can do... Please don't hate me for code like this. I know it's bad. So let's try this again. Oh, we lost the... Oh no, we didn't. It's just a weird order. So this is fine. Let's try to assign X. Let's see if you find the declaration. Yeah, that's the correct syntax. Is it the correct symbol? Yes, it is. Okay, we defined it. Let's try to reference it. All my breakpoints. How cool is that? We actually have a working REPL. Yeah, this is really freaking cool. Okay, I think this is a good place to stop because we caused enough hacks that we'll need to have a lot of cleanup before the next session, and possibly some things that we need to make better for the compiler. We might have one more session that will work on the REPL internals like this, with shadowing, but that might not be interesting work. So we might skip that, and we might jump into actually quality of life features when the REPL is cleaned up a little. It doesn't have so many technical hacks. So what I'm thinking is that we could start looking into things like syntax highlighting or even completion in the next sesh we will have. As far as I know, C# REPL, let me actually bring up the repository. So as far as I know, the REPL, this REPL thing that I use and love, exposes a library that should help us with that. So as far as I know, it's referencing some pretty prompt. Let's check that out. I hope that's a thing. It's not a thing. It is a thing. Yeah, so this should be a prompt that allows us to do syntax highlighting, completion, history, and more, which is something we will really, really want for our REPL as well eventually, when it's more feature complete and is ready to accept these services. The compiler already exposes your token types, so you can do coloring on it. We expose services to do completion, so it's hopefully not going to be that hard to integrate this into it, but we'll need to look into the API to see how easy that is. So what we managed to achieve is that we got imports working that are basically saved between sessions. and we made the context implicitly carry on. So you can see that we finally can define a variable x or a function add, and we don't need to reference it by the previous context's name, .name. We can actually just type it out like this. So this was a lengthier session than I planned, but are there any questions? I'll wait a few minutes in case there are any rolling in the chat. You can ask about the session we did today. You can ask about the compiler or the language in general. I'll be happy to answer any. Until then, I'll get a glass of water. All right, there are no questions. Wonderful. Thank you anyone who joined in, who asked questions, who initiated the discussion. The WOD will be uploaded soon, at least as soon as I can, and section it as usual. The next one might be a while, primarily because we need a lot of internal cleanup to do to be able to move on with more interesting features like coloring and completion. But it will come eventually. So thank you anyone who joined in, and take care. Bye guys.